I'm McGrail. I'm a technical artist working at Unity Technologies. I work primarily on the lightweight render pipeline. And today I'm going to show you more of kind of some of the new features that we've just created in the lightweight render pipeline. I know this was kind of said as an introduction to lightweight. I won't be going over too much of the basics. Just as a show of hands, who's played with lightweight? Dismount. Who's actually making a full-on game with it right now? Brave. No, we're coming out of preview, and to be honest, I'm very excited about it. I love working in it, and I love using it. So, just a quick one for those who don't know, you can get it via our package manager. So if you've got an empty project, you can just grab it up in Window, Package Manager. And then you'll see a big long list of packages that we provide in Unity out of the box. And here you'll find Lightweight Render Pipeline. This you want to install 19.1. You'll see here we've got 5.xx versions. And if you're using 19.2, it'll be 6.xx versions. But today I'm going to kind of show mainly this new kind of custom renderer stuff that we're adding in. So the future of lightweight's actually quite broad. It's going to expand out to a much larger kind of, I guess, aim than it originally was. First off, it was supposed to be just very lean, mobile only, super fast lightweight render pipeline. But we've realized that the customizability of it's really nice, the ease of use is really nice, and we want to keep expanding on top of that. So we're also adding in the idea of pluggable renders. So this makes it a lot easier for us to go, well, now we can make kind of like a really lean 2D renderer. We don't have to make a brand new, brand new render pipeline just for 2D. And this also means we can easily add in a deferred renderer later. What this kind of opens up to you guys is that if you're a bit tech savvy, you can write some code, you know a bit about graphics programming maybe, you can actually write your own renderers using lightweight as kind of a shell. So it means you don't have to do a lot of the setup, you don't have to understand scriptable render pipelines itself. You can kind of just come in here, see what we've done with our renderers, unplug it, put your one in, and can be good to go. So obviously that's great if you know how to code, but we want to also make it really easy if you don't know anything about coding to change the complete way that lightweight renders something. So that's what I'm going to show you now. So with the newer version of lightweight, you'll see this is the lightweight render pipeline asset, by the way. This one I have currently assigned under the graphics settings and the project settings. This is how then it will use this to render the scene. And what we've added now up the top is a render type. Now here you'll see there's a drop down, and it is currently set to the forward renderer. This is the only renderer we're currently shipping. In 19.2 we plan to ship a 2D renderer, and 19.3 we plan to ship a deferred renderer. So you'll see here also there's a custom option. Now this will get populated obviously with 2D and deferred later on as we make them. But custom lets you take one of our existing renderers, so a forward renderer, a 2D renderer, or a deferred renderer, and add your own little extras to it. And that's what I'm going to show you with this example here. So we can go custom, and now we've got a point where we can actually put in a brand new renderer. In our project settings, we can right-click, we can go create, rendering, lightweight render pipeline, and we can make a new forward renderer. Now this is just a scriptable asset, a scriptable object, sorry, and it's there essentially to hold information and have a list of passes that lightweight will use to render the scene. By making a brand new one, I'm just going to call this a little giveaway of what I'm going to do here, the outline, post effects. And with this, you'll see we've got our forward renderer, we've got a default layer mask. This is essentially an overall layer mask that acts on top of any camera layer mask that you may have set. I'll come into that later as well. You've got some overrides. But the main thing here is the renderer features. Now the renderer features are essentially scriptable render passes in the background. Scriptable render passes is our API to do fully custom rendering effects within the lightweight render pipeline. The renderer feature is a way that we can make an easy, nice to use list, kind of reorderable list version that you can have, any amount of settings on them. You can make your own ones. We provide one currently, But we're looking at this as being a really nice way to be able to extend lightweight rendering outside of the normal scope and add cool rendering extra features that you might otherwise, have to be diving into some code to try and do. So in this example, we've got some cartoony characters. You've probably seen them in a couple of our demos that we've been doing. They're really nice. But we look at this and this is the perfect art style where we would want toon outlines. Now toon outlines has been a big ask that we've realized a lot of the users have been wanting, and we wanted a way to be able to provide this almost out of the box with little to no configuration on your half. So originally you'd kind of do this idea with an additional pass on a shader. You'd have another pass that rendered that same object, maybe push the normals out, or you could do it as a post effect, taking the depth and doing some Webgl filter. So I'm going to first show the post effect because it's quite a simple one and it's nice and easy to set up. So if we click the add button here, we can see we've got a list of a couple of render features. Now these are actually existing only in this project currently. The render objects is being brought into Lightweight Render Pipeline. This project we're going to release as like a learning examples project, and we're going to continually upgrade it with more and more examples. But for this effect, I want to do a blit. So a blit is essentially a pass that renders on the GPU. It's going to take a shader, take a material, and it's going to re-render essentially a full screen quad in a way over the entire screen with this material and shader. So I'm just going to go and call this outline. And what I want to do is give it the blit material. Now, I went online. I didn't know how to write a Webgl filter by hand, so I've found a lovely one. But I'm just going to create a new material. Let's call this outline. And under unlit, I have this Webgl filter. Now, what we can do is we can use this material and assign it as the shader and the material that's used for the blit. Now, we've got it assigned here, and you realize, well, nothing's changed in my scene. It looks the same. What's this? And that's because I've made the custom forward renderer, but I haven't actually assigned it. I haven't actually told the lightweight to use this custom one that I've just made. So I can go back to my lightweight render pipeline asset, and I want to drag it up here to the data. Because right now, it's using the one that comes with lightweight. It's in the package, it's a read-only one, it's just a bare bones. So now I'll drag this post effect one I've just created up into the data slot. And now you'll see some toon outlines have appeared. Now, they're quite thin, the screen is quite giant, so I'll ramp that up a bit. But you'll start to see some nice outlines coming off the depth buffer. Now I've added some debugs into this shader just to make it easier to see what's going on, but we can turn outline only. Now, we can see the outline's really sharp around the characters and really defined, really nice. And then we look at the buildings and it gets quite thin, and something's not quite right here. So the cool thing about this is that because we're editing the actual render pipeline itself, you get all of the render pipeline advantages, and this means really good support in the frame debugger. So if we come down here to the frame debugger, we enable it, we'll see our mesh skinning from our characters. But what we really want to see is down here, we've got our opaques rendering, so this is our characters. And we've got the outline. And you go, well, the outline looks quite nice here. It's nice and thick around the buildings. What's going on here? And I go down to my next pass, it's the skybox. The skybox is actually eating into it because this outline pass doesn't write to depth. So it's in the wrong place. I actually want to change where this effect is getting injected into the render pipeline. Now, this is something that's exposed and quite easily to change. So here we have an event, and currently it's set to after rendering opaques. We can click this, and some of you who have maybe played around with lightweight and started doing some API calls will notice some of these. And these used to be callbacks of where you wanted to inject custom code. Now, the shift here was having a bunch of callbacks sitting in a render pipeline waiting for information to come in. Actually, it causes the pipeline to have to hiccup and try to, do I need to render something extra here? Is someone going to suddenly turn something on and something arrive? The way of doing it here is that you're kind of predefining what you want to render. So we can make a really nice lean list of all the passes that are in Lightweight Render Pipeline. But in saying this, I can go, actually I want this outline effect to happen after the skybox, because I don't want the skybox eating into it. So I'll change it to after. You see the skybox has disappeared, that's because we've gone down here to outline. Now if I disable, we'll see we're full screen, it's splitting over everything. But I can go back out of my debug look. And now I've got some decent thick outlines around the whole thing. And because this is essentially a post effect and I get access to the entire screen texture, I can add in things like a posterize filter quite easily. The cool thing about this is being part of like the actual deep code in the Lightweight Render Pipeline, being part of the whole process, is that this affects everything. It's in the scene view. If you make any reflection probes, it'll be taken into consideration there. You don't have to worry about attaching anything to any specific cameras. Just any brand new scene you make, you've got your Lightweight Render Pipeline asset assigned, everything will look like this style. And it makes it a lot easier to really change how the Lightweight Render Pipeline will look. So that's not the only way to do outlines. Another way is to essentially do another duplicate version of the mesh. That's what I was going on about before with the extra pass. Pushes out the geometry, makes it black, flips the normals. This gives kind of a shell around all the characters. Now, adding an extra pass to a shader, yeah, I guess that individual thing's easy, but what if you're using a bunch of custom shaders off the asset store? What if you're using a Unity standard shader? And, I mean, you don't want to open that thing up and try and add another pass to it. So what you just essentially want to do is just re-render some objects with those settings. So let's look at creating that effect. I'll start with this one. It's just named for its namesakes, but it's a brand new, empty, clean forward renderer. And let's use this one instead. Now we go back to no effect. Well, let's start setting up this one. In this instance, we'll use the render objects. Now the render objects is actually the one that's currently in Lightweight. It is experimental. We've got some UI stuff we need to iron out. But in terms of actually the functionality, it works perfectly and it's really, really useful. So I'm going to use this. And essentially what this pass is, it renders some objects again. It's got some overrides, it's got some filters. So we'll call this outline again. And first off, what do we want to render? Well, actually I'm thinking I might just put the toon outline around these characters. I don't want to put it around the entire scene. So if we have a look at these characters, they've actually been set up with a layer mask. So they're set to character up here. So I know I could use this as a filter. If I go back to my hull effect, I can say layer mask, instead of nothing, I want to be rendering my characters again. Now nothing obviously again looks like it's different. It actually is, and this is just because we're adding a render pass to render the characters again. They're rendering exactly again, like on top of themselves with the exact same shaders, the exact same place, everything. So we're just paying the cost of rendering them twice. But what cool things we can do, we can override some stuff. And in this case, we're going to actually override the material for these guys. So I've got another shader I've made. Essentially, it's quite simple. As I said before, pushes out the normals, flips them, and then just colors it black. And I believe it's tool, basic outlines. And let's assign that. Now we've got an override material. Pass index is turned up. That's essentially what pass of the material, the shader that you want to render. So you could have a shader that's full of all sorts of different effects and render different ones throughout different passes. But now you'll see a very small outline around these guys. Let's crank this up a little bit. And now we've got essentially toon outlines just around these characters. And the cool thing about this is it's not attached to those characters in any way. I can go in, we can completely change what shaders those characters are rendering with, we can change any of the textures, we can download a shader off the asset store and throw it on these guys and they'll still have their toon outline. It completely disconnects that kind of effect from the objects themselves, which makes it a lot easier to kind of customize and keep improving upon. And these characters work really well with the style. Now I will show another example here. Same kind of assets, yeah, they're really nice to use. But we've got this little guy, little mage, and he essentially just runs around these towers. There's a few of them. But in this example, we want to make sure that our characters can be seen as they walk behind these towers. Because currently, if you walk behind it, they disappear. You might be playing this character. You might need to know where he is behind this. So in this case, let's set up a new render pass for this in a custom forward renderer. I've got an empty, brand new one here, all ready to go. Let's just make sure that's assigned. Yep, up under the lightweight render pipeline asset, it's already assigned, so we're good to go. We can start creating this effect now. Now, first things, what do we want to do? We want to render the character when he's behind this. So we obviously have to re-render the object. This means we're going to be using the render objects again. Now, if any of you probably play Super Mario Odyssey, that's come out recently on the Switch, it's got a really nice kind of dither effect. When Mario goes behind an object, you can still kind of keep track of him. He's kind of rendered in this like dithered, pixely kind of view, and it's quite a good way to kind of do it without completely ruining what's in front or just rendering the character over top. So let's quickly set this up. Now, again, we want to choose the character, and we want to override the material as well. So I have a dither shader here. This one has actually been created within within the shader graph editor. It's quite a simple node setup. The dither node is actually a built-in node itself, so not much going on here, but just to show that it was completely set up without having to write a shader. Now we want to use this. So let's override and done. Now we'll notice, well, that hasn't really fixed the issue. The guy's just got dither over him now. He still disappears when he goes behind objects, which isn't exactly the desired result we wanted. So this is where we can start overriding some other things. And in this case, because the effect is we want to essentially render him on when he's behind something, we want to override the depth. So let's override this. And the reason he's not rendering, obviously he's behind something, but he's behind something in the depth. So his depth value is greater. And by default, if a depth value is less, we say, yep, render that depth value. This is called the depth test. And here it's saying if it's less, we'll render the object. If it's greater, we don't render the object. In this example, we want to do the opposite. So we actually want to test if it's greater. And now we get the character rendering over top of anything in front of him. Oh, we can play this, but it's still a bit weird. Now our character looks a bit goofy when he's running around. His arms are inside himself, and he's got some like extra glitchy bits happening. And this isn't ideal either. And this is because, yeah, his arm here is essentially behind his body. So we're going to say, render this dither effect. Now, this is because we're rendering the dither effect first. The dither effect after we've done the character. And we want to make sure we're actually rendering the character after the dither. So this is where we can actually use this default layer mask. So this is an overall, get rid of this layer in the default lightweight render passes. So we don't want to render the character with the default render passes. This solves it, obviously, but now we've got no character at all, which is kind of annoying. So now we have to now we need to add another render objects pass. So I will just name this one first before I get confused. Let's call this dither. And now let's add another one that's just going to render the character. And now our character pops back. We can see our dither effect's working as he goes behind. You'll also see that the dither effects actually change color. And this might be what you want. Like, we can still see all the textures on him. We can see his glowy face. He's as if he's rendering with a dither color. But we want to go back to that original shader color, which was kind of the flat blue. Now, the reason this is happening is because the dither path is actually writing to depth as well still. So the dither path goes, I'm behind something, I'm allowed to render. So I'm rendering down some depth values that are actually behind the tower that's now in front of me. When the character goes to render, it goes, well, I'm behind the tower, this pixel here, so I'm going to render. And we can just override this part as well on the original dither pass. And we don't want to write to depth. So, sorry. If we disable this, then we get our solid blue color back again. And our character, we don't lose him now going behind objects. Now this was completely done. There's no coding needed for this. It's a drag and drop setup. And it can be used for a wide variety of effects. We really wanted to make something that was easily to use and also quite customizability, because the idea of the existing system of actually having to change all of the deep code within Lightweight just to be able to add a certain rendering effect was not ideal for asset store publishers. Or even if you wanted to share an effect throughout different projects. And this makes this a lot easier now. So this project will be available on GitHub, and we will be, the current version of Lightweight actually has full support for this. It has the render objects pass, doesn't contain the other two. We're going to keep that in this project until we've refined them a bit more. And yeah, I'm really looking forward to seeing what everyone can do with this. And yeah, I hope you enjoyed the talk.
Are there any questions?
Hi, thanks so much. Would you recommend LWRP for VR, especially on, like, say, Oculus Quest?
Yes, definitely would. We're obviously working a lot to make sure it's super fast on mobiles, but that super speed, like the improved in performance, really helps out with XR, because obviously you're rendering everything twice.
Right.
So XR is definitely on our top list to make sure we get it working across all the different headsets and different platforms.
Awesome. Thanks so much.
How about Webgl?
Yes, so Webgl 2 works perfectly fine. Webgl 1, you'll have to drop back to gamma color space. We don't support linear color space. And currently there's a few lighting issues, but it works nonetheless. So if you start in gamma, then it works perfectly fine. But if you're trying to switch a project from linear to gamma, you'll run into some issues then.
Thank you. And WebAssembly is the same thing?
Sorry, can you speak up?
WebAssembly as well. So if you're building with WebAssembly?
Unfortunately, I'm unfamiliar with that.
All right.
Great, thank you.